Hey guys.
Hi.
Um, so let's. So I have functions and arguments that I want to discuss today. So let's go through this.
Can we do the quick review of global and local?
Um,
Okay, we are live now.
so let's. Yeah. So we'll do the global and local variables here. So I have some examples that I. Okay.
Kannan, can you just confirm you are able to share the screen?
Yeah. Can you see my screen?
Yes, perfect. Okay.
Okay. So let's start with here, right? I have different examples here, so let me walk through each one of them. So, we went through this last week, so it's kind of a review. Let me clear this. So, so I have a function called times, and it takes two arguments, x and y, returns x times y. So when I print this, I'm calling the function times, and I'm passing two values here. Okay, so if you do like times 5, it should give 25 times so it's polymorphic in nature, meaning that because there is no compile time binding, it's more of a runtime binding of the variables, right? It's a dynamic type that Python uses. So I can specify anything here. So if I do Python, it should give an error because it cannot multiply a string with itself, right? So that's one of the constraints with that, because it can take a string and then if you give an integer, it multiplies it. Like let's say this one, right? If I do phi comma Python, do you know what this will display?
Error.
No, it's the same.
Wow.
Multiplication, right? Whether it's 5 times Python or Python times 5, it's the same, right? Whether you say 5 times 3 or 3 times 5, both are same, right?
Yeah.
So that's what it means. So that's the function. Now the intersect, right? If you run intersect here, so the first thing we're doing here is we're we're declaring an empty string, sorry, an empty list. So there's nothing there. The result or the res is an empty list. And then we're sequence 1 is spam and sequence 2 is scam. So it loops through the spam and sees if S or each individual character is there in the second sequence, right? So if you do like F for X in sequence 1, if X in sequence 2, then we're appending the value of X to the result, right? So we're adding it to the result, and then the final result is returned from the function. Okay, so in here, S, A, and M are intersecting, meaning that those are the common characters between the two strings there. And the same thing with this, right? So if you pass this, the intersecting columns are 1 and 4. The 2 and 3 are not there in the sequence 2. Okay, so this is an example of how, it's not very specific to Python, but this is, you can use it in any different languages, just to show how you write functions in Python. So now let's go into the scopes, right? So we talked about scopes last week. So in Python, there is a global scope here, right? So when you're defining anything outside the function.
And then your voice is breaking up.
Is it better now or no?
Yeah, better.
Okay. The speaker is not working. Can you guys hear me okay?
Lot of disturbance.
Oh. How about now?
Yeah, kind of better, but still.
Is it better now?
Yeah.
Okay, it says your speaker is not working. Let me rejoin this.
Okay.
Any better? Can you guys hear me?
Yes. Yes.
Okay. So we have x equals 99 here. And then I have a function where I'm replacing the value of x. So it becomes a local scope. So when you run this code, you will see the value. So when I'm calling the function, right? So I'm x equals, I'm calling the function. The return value of x is assigned. The return value of the function is assigned to the value variable x. So it overwrites the value. So initially I have 99, and then when I execute the function, it inside the function, the value of x is reset to 120. But then, when when you print the X value here, okay, so let's do that, right? So when you print the value of X here, do you know what the value of X will be?
99.
Okay, you know why?
X is a global variable,
Right,
so you are calling it, and it's not within the function.
right, right. Is everybody else feel the same way? How many do we have in the call? Okay, all right. So what happens here is that, and Anita is right, um, because in the function, the scope of X is within this function, meaning that outside world doesn't know what this value of X is. It's, it's a new variable that's created within the function. It's visible only within the function. Outside the function, it's not visible. So when I print the value of X right after the function definition, it's always going to be referring to 99. And if I don't assign the value, let's say, if I assign the value of X is like Y equals a function, and the value of X will still remain 99, Y will be 120 because we're returning the value of the function returns a value of 120, right? So let's run this again. So you'll see that X is 99, right? Um, we're not printing Y here, so let's print Y. So you should see Y should be 120. X is 99, Y is 120. It's because the return value of the function is assigned to a variable called Y. And inside the function, we are resetting the value, or, it doesn't matter whether you're specifying this X or Y or Z or anything like that. It doesn't matter because the value that's being returned is this value, which is 120. And that 120 is assigned to a variable called Y. And when you print the Y, we get 120 here. Okay.
So I have a question, Shally, here.
Hmm?
So when you define the function, will it not conflict inside the function and outside the function if you have the same, like say X is 99 and X is equal to 120? How does the Python know which one to collect?
So it uses a formula called LEGB, and so when it goes through its local, enclosed, global, and built-in, right? So that's what LEGB stands for. So let me write down here. So it's local, enclosed, global, and built-in. So it parses through this, right? So when it hits the first one, it stops right there. So meaning that in this case, this is a global scope because it's outside of a function, right? It's defined outside the function. Inside the function, it looks at X and it says, oh, this is local to this function. Okay, so it stops right there. It means that it's a local scope. You can manipulate the value of X within that function. It doesn't care because outside the function, if you're still accessing the variable, so like think of it like this way, right? Let me annotate this. So if you look, draw. Okay. How do I draw a line? Doesn't seem to be working.
Well, I'll just try to understand very quickly so I don't waste others' time. Is that the reason why the first time it gave the result as 120, however, in the second time it gave the result as 99?
Yeah, no, it's important. It's a very good question. I'm trying to see if I can draw a diagram and show you this. So let me see, give me a second. For some reason, this is not working. Right. Ah,
You trying to get the whiteboard?
yeah. 1 second. Mouse pointer. No, just reset this. Annotate. Draw. Okay. So think of this as like this, right? So you have, this is your program, right? This is your function. And this is your Python code, like the arguments are ty, right? And then inside this, you have a function called, this is, let's write down. This is your function, okay? And text. So this is your functions Python module. So this is your functions.py. In here, we are specifying value x equals 99, okay? And in here, we're specifying x equals 120. Okay. So what happens is when this function is defined inside this Python module, right? This is the outer rectangle is a Python module. And in that you have a variable called x equals 99. And then the same x is used within the function x equals 120. So the way Python and any programming language, right? It's common across multiple programming languages that this is called the global variable. So this one is called the global, and then this is called the local variable. Okay, so let's see. This is global. And this is text, and this is local. So why this is global? You know, the global is that it's available for any code inside this functions.py. So anywhere I'm using the value of x, I can access the value of x. Okay, but when I go into a function, and if I don't specify the value x here is points to the global variable, Python will consider that as a local scope, meaning that that x will be created, that object will be created within Python, within the function. And then when the function is done and the code is executed, it'll be garbage collected and then it'll be thrown away, okay? It lives, it gets created and it lives within the function, it dies within the function. That's a difference between a global and a local variable, right? So imagine your, I don't know, I mean, just thinking of an object which lies outside your home. That's a global object. Anybody can touch it. Anybody can use it. Like if you leave unused furniture by the garbage truck, right? Anybody can touch that. That's a global variable. But the same furniture, if it's in your home, nobody can touch it. So that's local variable. It's a very crude example, but that's how the global and local variables work. Now, let's go into this example, right? So if I remove this line, so let's comment this guy. And I'm going to uncomment this guy, okay? So now, so what happens if I run this? So I'm seeing a value of x equals 99. And within that function definition, I am saying, hey, I don't want to create a local variable, but I want to point to a global. Okay. So, and then I'm assigning the value 88, but still I'm seeing the value 99 as my output. Can you guys tell me why that's happening?
So if you assign, if you say global x equals 88 right there, then it would be global. Will that print 88?
Because the global is overriding the local.
There is no, so sorry, let me answer your question, Shali, but Rishma, I forgot, I didn't follow what you were saying.
Okay, can we do that global x equals 88 right there? Then it is going to change the global value to 88.
Okay, so you're saying
Yeah,
equal
right
88.
there, initialization and declaration and initializing. Yeah, then on comment that.
Okay, and then run it again.
Yeah, will that should be 88, right? Oh,
No, that's a syntax error. Okay, so I don't think the global X, it allows that. So
I see. Okay.
so anyway, so the reason why this is not showing 88 is because I haven't called the function. So I need to call the function and then it becomes 88. Because it's the value is changed within that function. So you need to invoke the function. Right? So in this case, the global value is changed because within the function, I'm saying that, hey, the X is not a local variable, it's a global variable. Right? So again, going by local, enclosed, global, and built-in, when inside the function, Python sees that, hey, I'm referring to a global X here, right? So let's say, I make it as global Y here, right?
So it did change the global, right? So that is what I was expecting. Before it was showing 99, so I got confused there.
Yeah, because I didn't call the function.
I see. Okay. I was like, why is it?
The
Okay.
function.
Got it.
So Python, and that's important, right? In Python, and it applies to other languages too, right? This is a function definition, and the function, it loads into memory, and then the function is available for you, right? And you can call the function, and excuse me. If you call the function, then the function will execute. But right, and that's where the value is specified. Now let's see, when you run this shows 99 because it says I said global Y, and there is no variable called Y here, but it created a global variable. So let's say if I do print Y here, do you know what will happen?
88.
Yeah. So it created a global variable called Y, right? Even though I don't have a definition of Y here, I specified a global variable Y, and I'm assigning a value called 88, right? So in fact, I'm defining a global Y here, and then and I'm printing Y here. So let's say, I'll do a def func2, right? And print Y, okay? And I'll say f inside function2, oh, sorry. So if I call function2 here, so I can see the value 88, right? Because I'm defining the global variable Y in a different function, and I'm invoking or using that value in a different function because it's a global variable. So let's say if I do Y here, Y equals 88, right? Let's see. instead of doing global y, I'll say y equals 88. Now this becomes a local scope, right? So now you're going to get all kinds of error because first of all, this y is is unknown because it's not a global scope. It's a local scope to the function, this function definition, right? And so when you invoke the function, it does assign the value 88 to y, but then I'm calling the print function or invoking the value of y outside the function definition. And in the global scope, y is unknown. And that's why you're getting the error y is unknown, not defined. Is that clear?
So local has more precedence than the global.
I wouldn't say it that way because the local variable is confined to that function. So think of your things inside your home that's confined within your home, right? Nobody outside knows about it. So that's the reason why this y is unknown, because you're trying to access a variable that's unknown, that is not there in the public domain. It is there in a private domain, which is the function.
I understood your latest explanation, but I still am puzzled with the local, enclosed, global, and bulletin. Is that the order in which Python works to look for the local
Right.
first and then goes to the enclosed and
Yeah.
then to the global and then to the bulletin?
Built in,
So
yeah.
local is where it stops if it gets the result. If it doesn't, then it picks up for what is defined as the enclosed. And then if that doesn't, it then moves on to the global and then gives the result as the global.
Exactly. It stops wherever it hits first.
Okay, thank you.
So that's how this works. So we have do a function 2, and then you get inside 88. Now, so let's move on to another example here. So 3. So now this is a little bit of so I have a function called all global, and I have a nested function called all global inner. Okay, and I want to talk about a few concepts here, right? So let me erase this. To clear full drawings. So let's draw this is my Python. Then I have a function. And then I have another function inside this, right? So this one is all global. And this one is all global inner. Okay. So this is your okay. Now in here I have in the function in the main module, I have x equals 10, y comma z equals 1 comma 2. Okay, and so this is a global scope, right? X equals 10 and y comma z equals 1 and 2 is a global scope. These are global variables, globally available for any module, right? So as long as I explicitly call them inside my functions, that I am going to be using a global variable, or I'm going to be pointing to a global variable, these are available for us. So it's visible, I can access it, I can process it. So in here, what I'm saying is, I'm saying global, I'm pointing to global, the value of X is a global value, right? And so I'm declaring that. And then I'm saying, no need to declare Y and Z because it's LEGB rule. Again, because Y and Z are global variables, right? So it goes through the same concept like locals, enclosed, global, built-in, right? So when it sees X equals Y plus Z, it knows that X, I'm pointing to the global variable X, and then Y and Z are not local to this. First thing the Python will see is, hey, is Y plus Z, is Y a local variable? The answer is no. Is it enclosed? The answer is no. Is it global variable? The answer is yes. And it moves on to Z and does the same thing. It goes through that LEGB rule and says, okay, Z is a global variable. So I'm going to use that to add these two values, and X equals Y plus Z, which is value of 3. And I'm declaring another variable called T, which is local variable, because T is not in any of the things. So in here, I'm saying T, declaring T equals Y plus Z, right? And T is a local variable to all global, right? It is the scope of T is lies within these 3-4 lines. Okay, because it's inside that. So now I have another function called all global inner, which is a nested function, right? So like in this diagram, you have all global and then all global inner, which is a nested function. I can have another one, like for example, inside this, I can say define all global inner, right? And then I can put something else. So now this is another nested function here. So I can go any level deeper into this function hierarchy. Okay, so what it means is, now when I access, when I don't specify this value, so let's say I'm not specifying, I'll come back to that keyword non-local, right? When I specify T here, that the value of T is local to this inner function. Nobody else knows that, right? Because it again uses the LEGB rule. There is no reference to any global variable here. So it'll consider that as a local variable and then move on. And it will say, okay, I'm going to create a local variable called T that is applicable only to this innermost function. And I'm going to assign the value of 25 there and move on. Okay. But what I'm doing here is a slightly different syntax, which is if I need to access something that is part of my parent function, I have to use this called non-local. When I say non-local T, it means that it is accessing a global variable, which is in the function above, in the parent function above. So when I specify this as T equals 25, now initially T equals Y plus Z, which is 1 plus 2, which is 3. Now T equals 25. So let's see, how this works. Let's run this code. So now all I'm seeing here is a value of X outside the global, right? So it is at the same level as line number 40, meaning that X equals 10, Y comma Z equals 1 and 2. And I have two function definitions, all global, and there is an inner function called all global inner. So but I'm not doing anything. I'm not invoking any of these functions, right? So, well, actually, I'm invoking all global inner No, actually I'm not. I have to call all global. And when I do that, it'll call the all global inner as well.
Right.
But I'm not invoking the function here. So let's say, if I call all global, now it'll execute everything inside this, right? The first one it does is inside inner, right? Which is value t equals 25. Okay. The value t is 25. And now I'm stepping out of the inner function. I'm in the scope, right? In the all global scope. And inside that, I'm saying print inside global x. X is 3 because I've already assigned the value of x equals y plus z, t, which is 3. And t initially in all global was 3 as well, because t equals again y plus z, which is 1 plus 2. But then in the inner function, when I invoked it, I am pointing or overwriting the value of t to be 25. Okay, so that's what this value is. The inside global is t equals 25, and it prints 25. So the concept is same, right? Because I have a global value of x here, which I'm invoking, and I'm manipulating that value, and then I have a sub function or a nested function where I am also. So let's say, if I do non-local x here, and I will say x equals 2000. So it doesn't understand because the non-local is not binding, because this is not declared in my previous function, right? Instead, I have to use global, right? Because this is a global scope variable that I'm accessing, right? So let's do this. So when I call all global, now you will see that the value of x is 2000, because in my nested function, so I'm manipulating the value of x 2 times, right? In the outer function, which is all global. And then within all global, I have an all global inner, and I'm manipulating that value of x equals 2000 inside that. And the value changes here. So I'm going to pause here. This is somewhat convoluted and confusing. So, fire away your questions and I'll answer it.
So this makes sense because there has to be two different names. One referring global, as in the wider scope, and one non-local is just inside the function itself. So that
Right.
makes sense that there's two different names. Otherwise, it would get confused to which variable we are
Right.
talking about. So yeah.
Exactly. How about others? Anita, Shali, do you guys understand this?
Yeah.
Vashish?
Yeah. Great.
I
Okay.
just have one
Yeah, all
question.
good.
No, go ahead, Vishisht. I'll ask after you.
Oh, I had a question about so you can declare variables in the shell, right? So you can say that will be a global scope variable, right? So if you declare anything in the shell.
Well, that's a shell, right? It has nothing to do with the Python module.
But if you declared that, it would act like what type of declaration?
It's a global. Yeah.
Okay, good.
You mean in the shell here, right? In here. Right. This is what you're saying.
Yeah, right.
Yeah. Okay, Shali, you had a question?
I had a local cat emergency, sorry. So I didn't see whether you ran all global in the shell itself or you ran the entire.
No, I invoked all global. I can do both ways, right? So I can invoke all global here. So if I run this, it prints all the values here. You can do it anywhere. I didn't invoke it here, so I invoked in my shell. So when I
the
invoke all
result,
global, the all global, inside the all global, because as you can see, this is indented, right? So anything under so this whole section belongs to all global. So anything you define here will be executed. And it's important that this all global inner is invoked inside the all global as well, right? So without which these values will be reset.
So when you say all global bracket open and close and then print F outside the global, it is picking up everything under all global. Why do you need the print F outside global also as the last line?
Meaning that, so as you can see, the all global, because Python goes with indentation, right? So when you define a function called all global here, or any function for that matter, with a colon, everything underneath that function, anything indented means that it belongs to that function. So in the Java world, we'll use like this, right? You will say function, it will have a return value like int, right? I will say all global uh, like this and like this, right?
Okay.
So what this means is that I would have the curly braces, and I will write the code. So we'll say return value could be anything, right? So yeah, integer is a return value, and I can have parameters, arguments inside this function, and anything between these two curly braces is a function. Now I can have a sub function underneath that, and all global inner, and I can do this. So the scope is limited within. In other languages like C, C++, and Java, like the scope is defined by these curly braces, right? So anything within those curly braces belongs to that function. Whereas in Python, we don't have any of that syntax, right? So the only way that you can know that these lines belong to this function is the indentation that we do, right? So line 42 to 56 belongs to all global because it's indented. Everything on that same indentation belongs to all global. Now let's look at all global inner, and it has indentation from 47 to 51, right? So those.
I'm sorry. I think we digressed. That wasn't my question. I got that part. I understood that part. My question was, what's the need of the code and the 58? That's all I wanted to know.
Just to show you, the scope, right?
Is it
Meaning that
necessary to write that code? That was my question.
it's not necessary. It's just it is important to understand.
Okay, so when you say, so the result you're getting after you run this is, it's giving you the result of whatever is executing under all global quotes. That's what it means.
Yes.
Okay, that's all I wanted to understand.
Okay, cool. Any other questions? So the key point to understand is the global and the non-local, okay? So let's move on. So let's look at this, guys, right? For so I have a var as a variable equals 99 global variable. Then I have a function called local, and I have a function called global, right? So same thing, right? So what happens here is when you run this, you'll see the value as 6 here. So can you tell me why that's the case? Oh, 6 is before. Sorry, confused.
Should be 100. Huh?
No. Let's see. The 6 is here. Okay, let's run this again. And here it ran the code. Let's see, what do we have here? So when you run, so I'm not invoking global, right? So if I do glob1, oh no, sorry. you're looking at 100, the same thing, right? So because I am accessing, I have a so when I do local, nothing happens because I'm not touching any global variable, because the var is local to this function local. So nothing happens. I'm setting the value of 0. I can set any value. It doesn't matter. It's not going to change anything. However, in glob1, I'm saying I'm saying I'm not going to use a local variable. I'm going to use a global variable called var. And plus equals 1 means, this is equivalent to var equals var plus 1. That's what the plus equals means. It's a short form. So if you do minus equals and it subtracts 1, if it's plus equal, it adds 1. So
I
it's
have a
it's
question
another.
here.
Yes.
So that non-local works only for nested function calls, right? So I cannot refer the def local var variable in global one function as non-local var. It's
No, you cannot.
it's
Yeah.
only within nest. Okay, makes sense. Yeah.
Yes. You mean you're saying this variable, right?
Correct. Yeah.
Yeah.
If I want to refer
Because
that.
it doesn't know. Yeah, because what happens is Python knows that this is a local variable and it ends the scope there.
Voice is not clear at all.
Okay, got it.
Huh? Sorry, Anita, what is not clear?
Voice is not clear at all.
Oh,
It's just me, or everybody hears the same?
Yeah, sometimes it's breaking a lot, but yeah.
okay. Is it getting better, Anita? No.
Yeah, better now.
I'm on high volume. I have a good connection. I don't know. Maybe a Zoom issue. Not sure.
Sorry to interrupt, but I could not hear anything. So
Even now, or
now it's good. Now it's good.
okay, all right. Good. So now let's look at this function, right? Alt4. So in here, I'm doing global var. So there is another concept called, import a function, but for some reason it wasn't working in version 3 of Python, right? So you can import yourself here, right? So let's see if this works, because I didn't check this again. I want to see if this works. Okay. Yeah, I was playing with this, but I couldn't. Let me see if I can run this. Otherwise, we'll move on to another set of examples. Oh yeah, var is assigned. So let's. Okay, so if I do glob2. So here, what I'm doing is I'm importing myself. This is another way of doing it, right? I'm importing myself like the same function, right? So import functions, import myself, and then I'm specifying global var, which is 99 here, okay? And then when I print functions.var, it's 99, right? Print var, which is again 99, and then functions.var plus 1 equals plus equals 1, change the global variable. And so when I print, actually this one, now when I say var plus 1 equals 1, it means this is a local variable, whereas this is a global variable. So if I print this, let's see, So it does, make it as 100, and functions.var is also 100. So we are, you could invoke it in any way, right? So let's say, let's do this.
So when you
Um,
import functions, you are importing those two, local and global one, into global two. So we have
No, so
access.
let's do this 1 second. I think it's a little bit confusing. I'll go step by step here. Okay, so okay, so now let's run this again. Okay, so what happens here is that when I import functions, it imports the value. I'm within this global two. I have the visibility of var equals 99. Okay, and so let's try this one more time. Okay, so instead of saying I'm not going to be using global var, let's see if I run this again and do glob2. I don't even need to do global, because what happens is I'm importing the functions and then I'm printing the variable var, right? Please note that I don't have to use this global var, right? Because I am importing this function. I'm importing myself within this function glob2. And because of that, so as opposed to here in the previous example, where I had to use this moniker global x, I don't have to do that. Another way of doing this in a different way is import myself using the functions. Now, when I print this var, it's printing 99, and then I'm adding 1 to that function variable. And then when I print functions.var, it prints 100, because now I've added 1 to the variable. The variable is 99, and then I've added 1 to that, and the functions.var is 100, right? Now, if you print var here, right? So I will say outside of all functions. So when you run this here, the value is 99. Okay, so now if you do glob2, because I haven't invoked glob2, right? So the value of functions.var is 100. Now, what is var here? Okay, so it didn't update it. That's interesting.
Yeah, it's supposed to be 100.
It should be 100, right? Yeah, it didn't update it. Yeah, this is what I was actually playing around with it, and something wrong with this import functions. And
So when we do import in Java, it actually copies part of that code and it sort of puts it in there, right? So here in when we say import functions, the global variables are visible there. So that's what is happening in import function statement at 72. That var 99 is made visible there, or what exactly gets in that?
right. So let's try one more thing, right? So when you do a global here, it says this, right? Glob2. Maybe it still wants me to specify a global variable. Yeah, see, it's still not doing it. So the import functions is somewhat. I need to
Uh,
debug into
for the
this.
var, you commented that var plus equal 1. It has to be uncommented. Then only it will take the value 100, I guess. So.
At 76, they have var functions var plus 1, right?
Line 77?
Line 77. Okay, let's try this. I don't know. So you're saying that I can comment this guy, comment this one, and then this one. It should, okay. Yeah, see, it needs to have Yeah, you need to specify.
Comment global war, because global war has to be there, because war is a like global variable. So yeah, then might work.
Yeah. So
But we are trying to
avoid.
understand import functions here, right?
Yeah.
So
Yeah.
I think that's not working.
So this is what we want to do. Let's see if it works. Yeah, there's some issue with this. Um, yeah, it still resets back to 99, which is
Just
weird
leave
because
everything as is and uncomment the line 77.
this one. Yeah, then what's the purpose of this, right? The thing is, it's still we when you do the import, right? So my idea is that I don't want to use global, but I want to use accessor function like functions.var, right? So when you do that, let's say, let's comment everything, okay? Let's comment all these guys. So we'll just print, importing function print functions.var, okay? So outside all functions, log2. See, the functions.var is 99, right? Because it is able to access it, right? So if I do functions, so import functions. So it does add, yeah, there's some weird thing, right? If I print it, it prints it, but then when it comes out of the glob2, it resets it back to 99. So sounds like this functions.var becomes like it is considering this as a local variable. It's not an accessor variable. That's the thing. So
Otherwise, it should have printed 100 in the second line, right? Like where you said
exactly. Yeah,
functions.var plus equals 1, and you
right,
print var, it should be 100 right there
right, exactly,
in the
exactly.
shell too.
Yeah. It's so let's park this, and I want to come back to this, right? And why this is. Um, so let's move on to another example here. Well, it's little after 6. Do you guys want to take a quick 5-10 minute break, and then we'll start again?
Yes.
Sure.
Okay, let's regroup at 6:15.
Okay.
Okay. let's get started again. So I want to come back to this next week on this. So let's comment this, guys, and move on to other topics. I want to get a better example. I don't think I have a good example here. So let's move on here. So yeah, there's a new concept that I want to talk about. Okay, so alt, is everyone back? Sorry.
Yes.
Okay. So do you understand this construct? You know, I have a function called maker, and it takes a
Screen share.
oh, screen share. Sorry, sorry, terribly sorry.
Thank you.
So I have a function called maker, right? And then inside that I have a nested function called action, and it takes a parameter called x, and then it returns x to the power of n, right? So this is a very, very interesting concept in Python. So now when I run this code, and if I specify like maker 10, it just gives me a function pointer. It says, it basically means nothing, right? But when I say h equals maker 10, it saves a value of n, which is equal to 10 here, okay? Because I'm passing the value 10 um, as an argument to this function called maker. And now if I specify, um, let's say h of 5, so now this value is the value of x, right? So the first one it retains because that's a sequence of flow, right? So n goes first, which is the first one. And if I do h times h of 5, which is the second parameter, I'm getting this value. What this means is it's 5 raised to the power of 10. Okay, so what is 5 raised to the power of 10? It's 5 times 5 times 5 times 5. Okay, 6, 7, 1, 2, 3, 3, 6, 8. Okay, that's the value you get here, right? So 5 raised to the power of 10 is 9,765,625. So that's what it means, right? So like if we do n equals maker 5 and n of 5, it's 5 raised to the power of 5, which is 3125. Any questions on this? Can you guys hear me okay?
Okay, so the function is essentially returning a function. So maker is returning a function, and then you're giving an input to that function, and you're getting an answer.
Exactly. You got it. You nailed it.
So maker can be used to define different kinds of function. This is just an example.
Exactly. Yeah. So when you don't assign a value, because like Vashish said, right, this maker is returning another function, a pointer to another function. So that's why when I type maker of 10, it says function maker dot locals action blah blah blah. It doesn't make any sense. Basically, this is a handle to the inner function, right? But you cannot invoke the inner function with this kind of syntax. So you need to assign it to a variable, and then you have to pass a value to that variable again, and then it invokes the inner function. Okay, so there is another way of doing this as well. So here is, and let's comment this guy. So when you run, this is a lambda function, right? So lambda is like inline functions. So it's the same concept as above, but here I'm not having another function, right? So same concept, right? H equals maker 5 and H times 2, sorry, H of parameter 2 is 32. So this is 2 raised to the power of 5, right? So 2 times 5 is 32. That's what it means. So this is another representation, right? So we're using an inline lambda function. Any questions? So you can use a different approach as well. So let me comment this guy, 3.
So either way we can do it, right?
Either way you can do that, yes. Okay, so now, so there is another concept called enclosing scope X with defaults, okay? So this is another way of doing it. So when you run this code, F1 prints value 88, right? So within F1, again, we talk about, the non-local versus global variables. So within F2, I can either don't take any parameters, or I can set the default of X equals X, meaning that it expects a parameter X, but then I'm putting a default value of 88. So let's say if I put 100 here and run it, it takes 100 because the value X is local to the function F2, but instead of using 88, I'm assigning a value 100, and then it prints 100, right? So if I don't specify anything, it takes the global variable to F1, right, and prints that value. So another way of doing it, I'm just giving you various examples here, right? Let's take this one, Alt 4. So let's run this. So can someone read this code and tell me or walk me through on how, if you understood? Line 114 to 120. And why does it?
So I can give it a shot.
Okay.
Okay. So, well, we'll start with line 119 because that's what actually does something. So basically it's setting X equal to function, right? And function doesn't have any inputs. So the first thing function does is it sets a variable X equal to 4, and it defines an action, which basically says it's a function that takes an input N and uses the given X of 4 and raises X to the nth power, essentially. So now it's returning that function action. And so that's what x has been assigned to be, is that function. So then when it gives you x of 2, essentially, it's going to put in 2 for n, because n is the one input that the lambda function needs. And since x was already defined in function to be 4, action knows that x is supposed to be 4. So then it'll just output 4 squared, which is 16.
Exactly. You got it. Did others understood what Vasishtha just said?
Yes.
Okay. So Vasishtha, I know you have done Java programming. What do you think about, do you think this is powerful?
I mean, it's like everything else, right? It's as powerful as it is confusing. So if you're good enough to not be confused, you can definitely use it.
Right, right. Yeah, it gives you so many flexibilities, right? So if you're not careful, you could, I mean, it's so powerful that, you can literally write cryptic code within Python and nobody can understand it, right? Anita, did you understood? Rishma, Anita, Shali,
Yep.
any
Yes,
questions?
yes, I got it.
I understood this, but I didn't understand the one before of the 88, but that's okay. I think I'll mull over it and I'll get it later.
Yeah, it's, let me quickly explain that, right? So what this means is that when you call when you say, okay, the x equals x means that x is the local variable to function f2, and you're assigning the value of this value to x here, right? And when you print that x, it takes this value, which is a global variable to function f1, and uses that here.
It's okay. It's just a little confusing because of F1, F2, and x equals x. That is what is bothering me. I think I'll get it later.
Okay, all right. All right, so let's move on.
Kannan, I have a quick question.
Sure.
Like sometimes we just call the functions and sometimes we assign that function value to some variable. Then only like we get the values. So why is it so?
So it's a really good question. The reason why you would assign a value, a variable, because the function is returning a value, you need to capture that value if you want to further process it. So this is a great example, right? So in here, function definition, the func definition has got x equals 4. It has another action equals some lambda function, and it returns the value, the sub function called action. Okay, and you need to capture that because it says return action. Anytime when you say in the Java world and C++ world, you would put a variable here, sorry, a data type here like int or string, right? So that means that the function will return a value of that type, right? So in here, because it's dynamic typing in Python, you don't need to specify those things. You just say return action, and then you will need to, somewhere you have to catch that, right? So that's the catching part. So when I'm invoking this function, I have to invoke, so like if I run this guy, and let's say if I run this guy and just say function, right, without assigning it to anyone, you will see that it's returning this funky handle to the action function, because this thing is returning an action, and you need to capture that action somewhere. Let's say this function is returning, for example, 100. Okay, and when uh, oh yeah, so I have to comment these guys. So let's say you're running this function, um, and I'll say func. It returns 100. Okay, so the 100 is not captured anywhere, right? You need to assign it. So if you say x equals func, and print x, you'll get x equals 100. In this case, we're not doing that. We're returning another function, right, which is action here. And that needs to be assigned. So the answer to your question is, if you don't catch the return value, you cannot process it, process that value downstream, right? So here I'm capturing it in line 119. And if I don't capture the value in 119, I cannot process it further. I cannot process it further down line 119. If I just say function and then do nothing, right? You cannot further call that function and get the real value. So that's the difference between just executing the function versus capturing the return value and assigning it to a variable. I hope it's clear now.
Yeah. And in the line 107 to 112, so we are just calling the function. So the value it is printing is print x, right? Like 110. When it prints 88, is it a like 110 line?
Well, yeah. So yeah, let's run this again. Sorry. Okay, so F1, when I call F1, F1 is calling F2. Okay, and in F2, I'm assigning the value x equals 88, and that's what it's printing.
Got it.
If you, on the line 109, if you say define F2 and you say M equals X, and then you say print X, would it still return 88?
Sorry, what did you say? What equals 88 or X?
No.
What?
In the code 109 line, when you define the function F2, if you said X is equal to X, if you said, say, another alphabet, say M equals X, it would still return the value of X as 88, right?
Oh.
No.
Yeah, no, in this case, you would print, if you print M, right? Because X will always be 88. So if you print M, M will be 88.
Okay, that makes it more clearer to me, because if you say X is equal to X, it is messing with my head.
If we print X there, Kannan, we are not saying it's what is that keyword? We are not using the keyword, right? So that.
Yeah.
So is it? It's taking a function
Let's do
one
this.
X as 88.
Let's do this.
I thought
We'll say X equals.
No, just print. Just instead of M, just print X.
Yeah, we can do both, right? So let's say X equals, sorry.
I see where you were going. Thank you so much.
Plus equals 1, okay? And then we'll say print X, right? So let's do this. And also F1, let's say print X. Let's say so here it's not, because what it does is the reason why you're getting an error here is because local variable X reference before assignment, okay? Because it doesn't understand, right? So like if I do, because now X is not referring to the global variable. So Rishma, that's what I want to do this, right?
Yeah.
Because it's just taking the value, the global variable of X equals 88 and assigns it to M. And when you print M and M is 88, that's what you see here, okay? M is 88, but then so it uses the LEGB rules and then looks at it and says, X is a local variable and it's not defined anywhere. So you're trying to assign it to 1, right?
Correct. Yeah.
And so it throws an error message there.
So instead of printing M there, if you say X, it will throw an error because X is local here, right? So it will, it won't throw an error, it will throw a memory, some memory, garbage memory, I think, where.
So like this, right? That's what
Yeah,
you're saying.
yeah,
Right?
and
Let's
comment on,
these.
comment on it, yeah. Just print the memory of X or something.
So X is still, because it's local. What does it do? 88. 88 is outside of F2 is 88. F2 because it's enclosing, right? It's enclosing scope. Sorry, that's what it means. So it's enclosed. It's enclosed within this function, so it's able to access that.
I see.
So it's LEGB, right? Local, enclosed, global, and built-in. So it remembers.
What about that local, that the keyword that we used before? This is like a nested function, right?
Yes,
so
but you
to,
cannot modify it because it's when you try to, okay, so when you do X equals, it'll throw an error message, right? X equals X plus 1, right? It should throw an error message because in this case it stops. So again, the LEGB rule, right? Local, enclosed, global, built-in. When it hits anywhere, it finds like first is local. It's saying, is this local, right? It stops right there and says, okay, this is local.
right.
Unless you will say non-local. Okay. And when you do this, now you get X equals 89.
Right. Okay.
So the non-local syntax is used for nested functions, right? If it's not nested, so that's why this LEGB rule is very, very critical, right? So you need to specify the non-local. Otherwise, this X equals X plus 1 means that X is not defined and it's a local variable, and so it throws an error message.
Okay, got it.
Got it? Okay, so let me go back to put it back to the same thing. I have a problem with my mouse. It goes all over the place. Okay, so let's leave it that way. Let's comment all these guys. Okay, so we've reviewed this action thing. There is another way of also handling this action variable. So if I run this guy function X equals 4, so same thing, right? So if you call this, it'll return value. So let's say H equals so in here, it's 4 raised to the power of 4, which is 256, right? So initially it remembers the value of the value of X is passed manually, right? So it remembers X, and then the next time when I'm calling the H, which is basically the action function with another argument 4, then it raises 4 to the power of 4, which is 256. Okay. One last example in functions before we move to arguments. Okay. So let me comment this. Any questions so far?
So the X equals X in the lambda function, that's to basically enclose the X so that you can use it, right?
Yeah, it takes a value of X from here.
Yeah,
Right?
so if you didn't put that there, it would expect another value, right?
Exactly, yes. Excuse me. So here's another example, make actions. So I have an empty list called X, and then so let's see if you guys can understand this. So let me run this. So when I what happens X0 or H equals X0 H of 2. Can you tell me? I have done this, right? So what does it mean? Can someone explain me this?
Is it like we are just creating a function make actions? Then there is an empty list is created named X. Then we are using the for loop, and it will take the value from 0 to 4, and it will append it to this X and use this function like I raised to whatever value we provide, and then it will return this X list, and yeah, we are calling the function, and I guess we are um, uh, returning the first element of the list.
Okay. It's not very clear, Anita. You want to give it another try? Or?
No.
So what does range of 5 means?
0 to 4.
0 to 4. Okay. So what does this ax.append do? It appends values into this list, correct? It appends the values to this list. So, and the append takes a lambda function, okay? And it raises I to the power of X, right? So you have to go through that, right? So when you specify a value, um, so it takes from 0 to 5, right? So this one loops through 0 to 5. And so I'm going to stop here. I'm giving you some clues here, see if you guys can understand.
All I understood was the I value of I was 4, and it multiplied it to a value of X2, which is 4 again. Therefore, we got 16. But I don't know how to explain it in the technical terms.
Okay. So let's start again, right? So when you call the make actions, right? So it for X equals, let's see what happens here. Let's see, yeah, maybe here. Let's print this, and then you'll guys understand very easily. So this is all giving you all the functions, right? So well, this is not a good idea. Let me see. So the first one is range. So 0 to the power of X, right? So what is 0 to the power of X? It doesn't remember, it tries to remember each value of I, meaning that, it goes through a loop from 0, 1, 2, and 3, and 4, right? So when you specify, where did I go? So when you specify 0, you are taking the value of I is the first value, which is 0. And then when you do when I say H of 2, which means that this function x is looping through that 4. Charlie, what you said is right? So it 4 raised to the power of 2, which is 16, right? That's what it means right here. So the last value is 4 here. The last value of the range is 4. It remembers the last I. Okay, so 0, 1, 2, and 3, and 4. So the for loop will go from 0 to 4, and the last value of I is 4, because now you're basically, the loop is just a trick, right? So it just loops through the 5 values. The fourth value is number 4, so I is equals to 4. So now when I send h of 2, what it means is the 4 is already remembered, and now x is replaced with 2. So 4 raised to the power of 2 is 16. So the trick here is that it loops through the range. So let's say, if you are saying range of 10, what would be the value of these two? What would be h of 2 would mean?
81.
81, exactly. Because it's the last value of that range. 10 is 9, and when I say 9 times 9 raised to the power of 2 is h equals 0. H raised to the power of 2 is 81. Okay.
What is x within the bracket 0? What does it do?
You're not, you're basically passing nothing, right? You're just passing a value of the first one, right? It's passing a value when the first one is h equals x of 0, meaning that the make actions, right? The make action is called, right? And when the x equals make action, right? So you can do the same thing, right? If I comment these two guys, right? So, and I'll say run this again. So you have to call make actions, right? So, sorry. So it's giving you a weird, return value, right? Because it's returning the value x here, and it loops through 9 ranges, right? So you can see that this one is 0, this one is 1, this one is 2, and so on and so forth, because it's 9, right? Let's say you just put it as 2 here and run this. So if you do make actions, you will just see 2 of them. So you can see that the functions this and this, right? So why do we say x of 0? We're basically saying we want just the first value in that list. So when I say x equals make, or let's say a equals make actions. Okay, so now a will have these two, right? These two values will be assigned to a, and so we're just accessing the first index, right? So that's why we specify a of 0, right? Or you'll say h equals a of 0.
But
And
you are
h,
saying it remembers the last value of I, then what is then how come it is showing all the 9 values or 2 values or whatever it is?
it returns everything, but the last value is the one that it remembers. See,
Okay.
when you return x, it returns all the values here, but the I it's not persisted. All the values of I is not persisted. Only the last value of I is persisted.
Okay, got it. Thank you.
Okay.
So if you did a of 1, it would be the same thing.
If you do
Instead
a
of
of
a of
1,
0, you'd still get the same thing.
Okay, let's try that. So h equals a of 1. Yeah, it's the same.
Oh, okay.
It's very interesting, right?
Yeah, but why do they all remember the same last number?
Because
Why
you're
is
not
that?
persisting, right? Because the I loops through, the for loop loops through, the I variable starts from 0 to 5, right? And it just remembers the last value because the I is not persisted anywhere. I need to think through this for a better example, but this is the idea, right?
Yeah, the idea is like it can't really run it once it gets the I, it can't run this, so it has to wait.
Right.
But by the time it's done and it's run everything, I is just 2, so it's just gonna run it
Exactly.
a bunch
That's the
of
point, right? The last value is the one that is persisted.
Right. Okay.
All
So
right.
when you write the code and if you want the h is equal to a of 0, you could incorporate that in the code if you needed that.
Incorporate in the code. I'm missing the point here. So
whatever is in the shell, the last 2 lines, which resulted in 1, if that needs to be a part of the code, you can go into the code instead of being.
Yeah. You can do that. Yeah.
Okay.
Yeah. See, the benefit of shell is that you can play around and get some values, and then you can put it back in the code. I mean, I had it in the code, and I uncommented because Anita had a question. So
No, I was just trying to understand if I am reading a fresh code written by somebody, I need to understand how to read it. That's all.
yeah, like this, right? So print h of 3, right? So if you do this, it will. Yeah. So it does the same thing.
Thank you for your patience.
No worries. So I think we're almost 7 minutes to this. I have another section on arguments. I think this will be a logical stop here, and then we can take on arguments. I have lots of good examples there. So because functions is so complicated, so next week we'll again do the functions, and then we'll go through arguments again. Okay.
I am okay with it. Thank you.
All right, guys.
Okay.
Thank you very much.
All right.
Bye.
Thank you.
Bye.
Thank you so much.
Thank you. No problem. Bye.